Area of composite shapes. Example 1. One side of the house looks like the following below. So new siding is needed, which costs $1.65 per square foot. So find the square footage of this one side of the house. So we can see that we need to break this down because you have, right, like the roof area, which, right, is a triangle, and below we have a rectangle, or we can call it a parallelogram to stick to the wording in this. So if we need to find the area, we need to break it down. So, because these are two different areas, formulas that we're going to be using, and then we're going to find them separately and then add them together. So let's just go ahead and look at the triangle first. So we have 6 feet and 30 feet. So let's go ahead and just rethink this. So we have 6 and this is 30. Well, to find the area of a triangle, just do it like that, it's going to be 1/2 base times the height. So let's go ahead and fill this in, right? So the base, right, is going to be this 30, and then the height is this 6. So let's go ahead and fill that all in now. So area of the triangle is 1/2, 30, and then the height, which is 6. So let's go ahead and we'll just get our calculators out. So let's go ahead and go 30 times 6, which is 180. And now we can times it by 1/2, or we can just go ahead and divide it by 2, which is the exact same thing because 0.5 or dividing it by 2 is the same thing. So we're just going to take this and half it, right? So what's 1/2 of 180? Well, that's just 90. But we can double check. Divide by 2 is equal to 90. So we have 90 feet squared, right? And this is for the area of the triangle. Now for the parallelogram, let's go over that area. So the area, which is just the base times the height. So our base here, right, is going to be 30. And then our height, which is 14. So let's go ahead and fill that in. So base 30, then times the height, which is 14. And what do we get? So let's get our calculators out. 30 times 14, and that's just 420 feet squared. Now we need to find the area of the whole side. So we're going to take, right, the total area is equal to the area of the triangle plus the area of the parallelogram. So let's go ahead and calculate. So 90 plus 420. So we just go ahead and add 90 and we get 510. So what's the total? We get 510 feet squared. So that's how much siding we need to think about. Now let's look at another example. Example 2, find the total area of containment for the giraffes at a zoo. So you can see we have a weird shape here. It kind of looks like a full rectangle, but it's not, right? It's either, you can say this little part is missing, right? Right here. So what we could do is we could find the full area and then subtract this part, right? So the full rectangle and then subtract like if we were to say this was the full rectangle, we would find the whole area of that and then just subtract this small little part. Or another way we could do this, right, is just break this in to two parts. So we have a rectangle here that we need to solve for, and then we need to solve for this one. So there's two different ways, and right, you can always think about how there's multiple ways to get your answer, and there isn't a right way. But let's go ahead and just solve for these two parts, and then we'll add them together to find the total area. So if we're looking, let's go ahead and just break this down. So the bigger rectangle is going to be these dimensions. And then if we look at the small little part right here, right, the blue, let's look at that. So right here is 96, but we don't know what the width is. We know the length, but we don't know the width. And all we'd have to do is see these two numbers. Well, obviously this is going to be, right, up to here is going to be 288, and then whatever is remaining gets us to 336. So in order to solve for this portion, we're going to go 336 minus 288. So let's get our calculators out. So that's just 48. So this little portion is 48. And we can double check, right? So if you had this, which is 288, and we said this was 48, let's make sure that's 336. Yeah, and that's 336. So we know we did it right, because we know this is 288, plus if we said we want to double check this 48 to get us to the full length over here, it's 336, because 48 is that small little portion. So now we can go ahead and solve, because the way we solve for rectangles or parallelograms is, right, our formula is base times the height. So let's go ahead and solve for this one first. And all we would do is to find the area is going to be 240 times 288. So let's get our calculators out. And that's going to be 69,120 meters squared. Right, the little m means meters. Now, if we were to find the area of the smaller one, let's get our calculators out again. We go 96 times 48, which is going to be 4,608. So the area is going to be, right, we did 96 times 48, and that got us 4,608 meters squared. Then to find the total area, we add, right, these two numbers together, so we get bring out our calculators. Since we already have this number, let's just go ahead and add that number to it, and we get 73,728 meters squared, and that would be the total area of the containment.